I'm going to be walking through how to do every algebra question on the SAT. This video will be part 3, which we're going through every linear equations with one variable question that is classified as hard. So it has the highest level of difficulty. So you can see we've got all the questions have the difficulty. They should all be 3 out of 3. They're linear equations in one variable. And every question has the question ID up top. In the description below, you can see I have timestamps for every single question. So the timestamps list what times, you can click on them, get to the question. They list what the topic of the question is, and they'll give you the question ID. So if you want to search for specific topics, or maybe if you did some of these problems and you're looking for a specific walkthrough of the problems that you've done, you can use that to search. These ones are specifically the algebra questions related to linear equations in one variable. These are the high difficulty ones. You can look at other videos I've done that walk through all of the easy, all of the medium problems. In the future, I'll be doing some problems that have all the other algebra problems and then other topics as well. And let's dive right in. So we have this one. Hector used a tool called an auger to remove corn from a storage bin at a constant rate. The bin contained 24,000 bushels of corn when Hector began to use the auger. After 5 hours of using it, 19,350 bushels of corn remained in the bin. If the auger continues to remove corn at this rate, what is the total number of hours Hector will have been using the auger when 12,840 bushels of corn remain in the bin? So the total number of hours, not how many from the 1950, from the very beginning, right? So the 19,350 is just to help you find the rate that it's going down. So we have 24,000, work for 5 hours. R is like the rate, so it's going down this much per hour. So 5 times R, how much it's gone down, and that would be 19,350. So we could subtract 19,350 from both sides here, or just from the original to see how much it's gone down. And it's gone down, it looks like 4,650. It went down 4,650 in 5 hours. So 5 times the hourly decline is equal to 4,650, which means that the hourly decline, so how much it went down each of those hours, is just this divided by 5. 5 goes into 40 8 times, so it's 800 plus 500 would be 100, so it's 900. Their 150 would be 30 times. So we have 800 plus 100 plus 30, that's 930. So 930 is equal to R. So every hour it goes down by 930. That's your hourly rate. So if we write it out, you have 24,000 minus 930 times the number of hours, right? They gave us the number of hours was 5 originally, but we're trying to find how many hours it would take to get down to 12,840. So now we're just solving for what H is. What is the number of hours? It did say in hours. Total number of hours. Just get the H term alone first by subtracting 12,840 from both sides and then adding 930H to both sides. Right, so it gets rid of the 12,840 over here. It gets rid of the negative 930H over here. 930H, this is going to be the total amount it declines in that time, which is the difference between 24,000 and 12,840, which should be 11,160. In H hours, it went down this much. And then to find what H is, we just divide it by that hourly rate, which is 930. We solved for at the beginning. So there's kind of 2 questions in one. Like first, let's find the amount it goes down per hour, and then use that amount it goes down per hour to find how many hours it takes to get to 12,840. H is equal to 11,160 over 930. Now, if you're on the test, just type this into your calculator. I do not have my calculator on me, so I'm just gonna, I guess, do long division. It's gonna be the same as 1,116, divide both by 10, like that. And they're both divisible by 3. It's 1 plus 1 plus 1 plus 6. 6 divided by 3, this would go in 372. So this is 372 over 31. 372 over 31 would be a little bit easier to do with long division. So it goes into there once. We have 6, goes there twice. All right, so H is equal to 12. And to check that, which is easier to check with your calculator, you could go 930 times 12 would be the amount that you lost, and that should be equal to 1160. It would be 9300 plus 2 times this would be 1860. 6, 0, this would be 1, this would be 11,160. Okay, so that's correct. So 12 hours, and we'll go down that much. Which makes sense, right? It went down not quite half as much in 5 hours. So since they give you these options, if you say you were really pressed for time when you got to this question, or you think you're going to be pressed for time, you could just try to logic it out and just be like, all right, well, it went down by less than 5,000 in 5 hours. So if you want it to go down by 11,000, like over 11,000, it's going to be more than double 5 hours. So it's going to be more than 10, which none of these are more than 10, right? So if you really want to do it quickly, you could solve that in under a minute just doing it that way. Now, even, doing it this way shouldn't take as long as I just did to explain all that stuff. And also, don't waste your time doing long division on your paper. Just type it in your calculator. But I'm just trying to show that it is doable even without a calculator. Say your calculator dies in the middle of the test. Don't freak out because you couldn't figure it out. But if you're really trying to manage your time, don't waste it with something silly like that. But that is a trick to do that. And then maybe if you did that, you rush through, be like, okay, well, I know it's more than 10, so it can't be any of these first three. It's got to be D. Then maybe put a star next to it. Be like, well, if I have time at the end, I will come back and redo this question. We have a factory makes 9-inch, 7-inch, 4-inch concrete screws. During a certain day, the number of 9-inch concrete screws that the factory makes is 5 times the number N of 7-inch screws. So let's just write let N equal the number of 7-inch screws. And the number of 9-inch screws is 5 times. So let 5N, you don't need to write let. I think just one of my teachers made us do that when I was in pre-algebra. So it's a habit that still comes back sometimes. This is the number of 9-inch screws. So N is the number of 7-inch, 5N is the number of 9-inch, right? 5 times N. And the number of 4-inch concrete screws is 22. 22 4-inch concrete screws. During this day, the factory makes 100 concrete screws total. Which equation represents this? So without even looking at the equations, I'm just going to write out what we know. N is the number of 7, plus 5N is the number of 9, plus 22 is the number of 4. And then those are all the types of screws they make, right? There's no other screws. That adds up to 100. Right, so it should be something like this, which you can combine your like terms. N and 5N gives you 6N. So 6N plus 22 equals 100. So it could be either of these forms. Yeah, okay, this is multiplying it by 7 and 9 and 4. That would be if there were 100 total inches of screw, which would be a weird way for them to give you the information, but there are 100 screws, right? It has nothing to do with the length of the screws. So the 4, 7, and 9 don't actually mean anything for this equation, right? So you can eliminate that. I can eliminate that. That has nothing to do with it. And then, 6N. So the 5N is just forgetting to add in that extra N. 6N plus 22 equals 100. Perfect. Alan drives an average of 100 miles per week, or each week. Same thing. His car can travel an average of 25 miles per gallon of gasoline. Alan would like to reduce his weekly expenditure on gasoline by $5. Assuming gasoline costs $4 per gallon, which equation can Alan use to determine how many fewer average miles M he should drive each week? He wants to save $5, $4 per gallon. How many fewer gallons would he need? I'm just thinking, right, 1 gallon would save $4. He wants to save 5, so it would be 1 plus a quarter of that. So 1.25 gallons. 4 times the number of gallons equals $5. And that's the gallons saved, so fewer gallons. Divide both sides by 4, and you get that you want to travel 5/4 fewer gallons, which is 1.25, right? 1 1/4. It's to use full gallon and then a quarter of a gallon less to save $5. That's just part of the question. Now, Alan drives an average of 100 miles per week. I don't think that will actually matter. How many fewer average miles he should drive? Because if they wanted to say how many total miles should he drive to reduce, then it would be 100 minus the amount or whatever. It's just how much do you want it to go down? And it's 25 miles per gallon. 25 miles per gallon. So you need to figure out how many miles fewer. Oh, what are they doing? Okay, they're doing something a little bit different. I think the 95 is the red herring here, because that 100 is just not actually important for this. It doesn't matter how much he drives previously, it's just he has to drive how many fewer than that. So 25 over 4. M is the number of miles. So this is kind of unit analysis. You want to have the 25 in the bottom because it should be $4. And then down here is 25 miles per gallon. It's $4 per gallon times the number of miles, so X miles. Right, so if you write it that way, just looking at the units, right, this would give you miles divided by miles, which would cancel out. We have divided by gallon in the numerator and the denominator. Those will cancel out. And you just have dollars in the numerator, which would stay. So this would end you with the right units. So it's going to be D. But I want to explain that a little bit more clearly. But you could just, write out your units, make sure that you end up with the units that you're supposed to have. But essentially, he wants to save $5, right? So that's why 5 is over here. 5 is the ultimate goal, is saving $5. Okay, I'm going to put the unit just so you can keep track of it. M is your number of miles. So how many miles do you have to drive to save $5? Well, 25 miles per gallon. So essentially, if you wanted to know how many gallons you have to do, which we did above, right? The number of gallons you have to save is 1.25, which is 5/4. You'd set it up like this: 4 times the number of gallons equals 5. So that's why the 4 can be up here. But to figure out how many gallons you need to do the number of miles divided by the miles per gallon, right? Because miles divided by miles per gallon, the miles would cancel, and 1 divided by 1 over gallons would give you gallons, right? So essentially, right, if you go 25 miles per gallon, mpg, but I'm going to write miles per gal, right, the number of gallons is in the denominator. So if you put this down in the denominator, it's like you're flipping the gallons up to the top, and then m can be your number of miles. So miles and miles cancel. You can think of it as like it's 1 gallon for every 25 miles. Right, so now we have the gallon. That's the same thing as 25 miles per gallon, 1 gallon per 25 miles. Right, so you write it like that. So it's how many gallons you need to drive 1 mile? It's 1/25th of a gallon. So 1/25th of a gallon times this original thing. So you can think of it that way. I know like the unit analysis way would be probably how I would do it, just to make sure you could keep track of it and you could do it quickly. But yeah, essentially you're converting this 25 miles per gallon, or you're inverting it. So you're making it 1 gallon per 25 miles. So you can calculate the number of gallons using that mileage that you have, right? Because M is the variables there. Using M, you'll find out how many gallons you need to go that many miles. Find it that way. How many solutions does the equation 10 times the quantity 15x minus 9 equals negative 15 times the quantity 6 minus 10x have? This is going to be one where it's either infinite, 0, or 1. There's no way to do exactly 2 for a 1 variable linear equation, or a linear equation in general. If it was like a line in a parabola or something like that, then they could have 2. Or if they're asking how many zeros does a parabola have, it could be 2 or 1 or 0. But in this case, right, this is linear. Right? You can look at your linear equations with 1 variable. So we're just finding out basically if the left and the right side are exactly the same, or if they cancel out to be the same, then that would mean there are infinite solutions. If they're just different coefficients in front of the x's, then there's just one way to solve it. So if you can find an answer for x, then that would mean there's one solution. And if you've got the same coefficients in front of the x's, so the x's could cancel each other out, but the constants are different on the two sides, that would mean that they're never going to be the same. So essentially, like if you had x plus 1 equals x plus 3, that's never going to be true, right? There's no value of x that makes that true. Even if it's 7x and 7x, 7x plus 1, 7x plus 3, right? That's never true. But if you had 7x plus 5 and 7x plus 5, right? Those are always the same, right? No matter what x is, 7x plus 5 is always equal to itself. Whereas, if you had 2x plus 5 and 3x minus 2, right? Whatever it is where they're different x's, then you could solve it. That would just be one solution. This would be 1, this would be infinite, this would be 0. Right, so it'd be something like that. We just distribute this and figure out which of those is the case. 10 times 15x would give you 150x. 10 times negative 9 would give you negative 90. Equals, let's see, negative 15 times 6 would give us negative 90 as well. And then negative 15 times negative 10x would be what? Plus 150x. So you've got 150x on both sides and negative 90 on both sides. So that's going to be infinitely many solutions. But those two things are identical. We have 3 times the quantity kx plus 13 equals 48 over 17x plus 36. In the given equation, k is a constant. The equation has no solution. What's the value of k? All right, so it's the same thing that we were talking about in the previous problem, where if you have the same coefficient in front of x on both sides, so basically the x's could cancel out, right? Like in this example here, 7x plus 1 equals 7x plus 3. You could subtract 7x from both sides. You get 1 equals 3. That's never true. So that would be when you have 0. So this is a 0 solution one. So you want to have the same term in front of the x. So 48 over 17 here, it should end up being 48 over 17 here as well. And then it will just be a different thing for the constant term, which we could already see. 3 times 13, that's going to be 39. We have 39 plus, and this is 3 times kx is 3kx. 3kx plus 39 equals 48 over 17x plus 36. So we've got the constants being different already, which is no solution. That means, that part is the same, but the coefficients in front of the x need to be the same. So that means that 3kx should be equal to 48/17 x. And now we can divide both sides by x essentially and just be 3k is equal to 48 over 17. So now to find k, you just divide both sides by 3. Right? We found 3k here. Just divide by 3, divide by 3. That gives us that k is equal to, well, 48 divided by 3 is 16. So 16 over 17. I think they do accept decimal answers. In this case, you'd have to round it. I'm just going to leave it as 16 over 17. I'm going to check that. 3 times 16 over 17 give you 48 over 17x plus 39. Right, so they'll have the same slope essentially. It's like if you graph them as two lines, that'd be two lines that have the same slope but different y-intercepts. One's at 36, one's at 39. They would never cross, right? If you want to think of it in terms of linear functions. A certain product costs a company $65 to make. The product is sold by a salesperson who earns a commission that is equal to 20% of the sales price of the product. The profit the company makes for each unit is equal to the sales price minus the combined cost of making the product and the commission. That makes sense because you get the money from the sale, but then there's costs associated with it and they have to pay the salesperson the commission. So if the sales price of the product is $100, which of the following equations gives the number of units U of the product the company sold to make a profit of 6,840? Costs $65 to make. So for each one, they sell it for $100. They had to pay $65 to make it, or like that's the cost of making it. And the salesperson makes 20% of the sales price. So 20% of the 100, so it's $20. So for each one, the profit is, 100 minus 65 would be 35. 35 minus 20 is 15. So the profit per unit is $15. They want to make $6,840 profit. So that's 15 times the number of units is equal to 6,840. Which of the following equations? Okay. So I jumped ahead of myself here. You have to find, well, I guess you could just, simplify all of these and find which one is equivalent to this. So they all have the 6840 over here. So you just have to figure out which of these sides is equal to 15u when you simplify it. You can do it that way, or you just look at like what they're doing with them. It's not this, because this is multiplying the commission. Also, why are they losing 0.8? That doesn't really make sense. This one just doesn't make any sense. But they're also multiplying that by like the post-sale price or the profit that they had before it. It's supposed to be 20% of the sale price. So here we have 100 times 1 minus the commission. Okay, so they have the money left from the commission or after the commission, and then they also subtract 65. This one is looking good to me, but let's look at the other ones. 0.8 times 100 minus 65u. But this is only multiplying the negative 65 times the u, right? This would actually work if you had this in parentheses. If it was like that, that would work. Because it's the same thing, 1 minus 0.2. Because there are no parentheses, you're just multiplying the negative 65 by the u. It's not that one. And then here, 0.2. Now this is multiplying, this would be like the amount that the person makes from commission. And then you're adding 65. It's supposed to be subtract the cost. All right, so this one's just backwards. All right, so this is going to be A. And then if you did it the way I did it, where you like solved it first yourself, that works. But here you get 1 minus 0.2 is 0.8. 0.8 times 100 is 80. And then 80 minus 65 is 15. So you end up with 15 times u here, which is the same thing that we had. All right, so that checks out as well. Here we have 2 times the quantity kx minus n is equal to negative 28 over 15 times x minus 36 over 19. In the given equation, k and n are constants, and n is greater than 1. The equation has no solution. They love these no solution, infinite solutions questions, whatever. What's the value of k? All right, so it's the same thing where if n is greater than 1, do you have to do anything with n? Well, if it was 1, then that would be negative 2, which is, negative 2 is negative 38 over 19. Yeah, so that works out. If it was 19 over 19 exactly, it's going to be a little bit more than that. That'd be 2 times that is 38 over 19, so negative 38 over 19. So no matter what, it's not going to be 36 over 19. So, going back to the same thing, the only way that for a one variable equation that it's going to be 0 solutions would be if you have something like 2 is equal to 0, right? That's never true. which the only way you'd get that is if you had something like x plus 2 equals x, or right, it could be something different too. It could be like 5x minus 7 equals 5x minus 9. Right, the 5x minus 9 is always 2 less than the other one. These are never true. There's no value of x that will make these two equal to each other. So in this case, right, our constants are different just because of this n is greater than 1 part. So all we have to focus on is that the coefficients for the x term should be the same, right? Because you want to have them almost the same, right? So it's like if you graph them as two lines, they'd have the same slope, but they just have two different y-intercepts, so they'll never cross. There's no point where this is equal to this. So if we distribute this 2, we get 2kx minus 2n, then negative 28 over 15x minus 36 over 19. So we already established this part, the constant being different. Negative 2n is never going to be equal to negative 36 over 19 because n is greater than 1. So that part checked. Now, the other part we need is the coefficients need to be the same for the x term. So 2k times x needs to be equal to negative 28 over 15 times x. Essentially, you just say this is equal to this. 2k is equal to negative 28 over 15. So what value of k would make that true? We just divide both sides by 2. Divide by 2. Cancels out. This is k is equal to negative 14 over 15. And that would be your value of k. All right, and just check that. 2 times negative 14 over 15 is negative 28 over 15. They'll have the same slope, right? The same value of the coefficient in front of x, but they'll have two different y-intercepts, essentially. So they will never cross, no solution. I'm treating it as if these are two different linear equations. But yeah, there's no value of x that will make these two equal if k is negative 14 over 15. Here we have 5 times the quantity t plus 3 minus 7 times the quantity t plus 3 equals 38. What value of t is the solution to the given equation? All right, so the key here is just when you distribute, because we're going to be distributing this 5 to the t and to the plus 3, and we're going to be distributing the negative 7 to both sides like that, make sure that you distribute the negative as well as just the 7, because you're subtracting 7 times t, and you're subtracting 7 times 3. All right, so it's going to give us, in this case, 5 times t is 5t, 5 times 3 is plus 15. Here we have negative 7 times t is negative 7t, and negative 7 times 3 would give you negative 21. Right, that's going to be the main way that people mess this up, is they're going to do plus 21. Just take your time there. And then that is equal to 38. And we're just solving for t. So we have 5t minus 7t, which would give you negative 2t. And then 15 minus 21 will give you negative 6. Yeah, let me just show what I'm doing here. I'm doing combining the like terms. 15 minus 21 is negative 6. That's equal to 38. So it looks like t is going to be negative. Add 6 to both sides to get the t's alone. That gives us that negative 2t is equal to 38 plus 6 would be 44. So if we divide both sides by negative 2, now some people, I said that to one of my students once, and they said, or maybe I said I multiply by negative 1. Multiplying by negative is the same as dividing by negative. It just will make a negative positive. It will make a positive negative. So the negatives cancel here, 2's cancel. We're left with t is equal to 44 divided by negative 2 gives you negative 22, right? Positive divided by a negative gives you negative. 44 divided by 2 gives you 22. So t equals negative 22. And just to check that, we'll plug it in. So 5 times quantity negative 22 plus 3 minus 7 times, again, quantity negative 22 plus 3. We want this to equal 38, right, if we did it correctly. Negative 22 plus 3 is going to be negative 19. 5 times negative 19 minus 7 times negative 19 equals 38. You can think of this as, right, you've got 5 negative 19s, and then you're subtracting 7 negative 19s. You have negative 2 negative 19s, which would be positive 38. Or let's just multiply it out. 5 times negative 19 would give you, let's see, that's negative 95. And then minus a negative. Negative times negative makes a positive. That'd be 70 plus 63, which would be 133. So 133 minus 95. Carry this down. So let's do 13 minus 5 would be 8. And then 12 minus 9 would be 3. So 38. So you get 38 equals 38. That checks out. You just do that in your calculator as well. So that did work. This would be probably the main way people would do it. You could also substitute something in for t plus 3. Just make sure that you do that back at the end. So say we did like, let's do a star. So star equals t plus 3. I'm going to do the star just because it will stick out in my head. Like I'll remember that that's not what I'm solving for. Right? I'm not solving for t plus 3 here. We're just solving for t. But this, potentially could make it a little bit faster. So 5 times star, right? Here's your star, t plus 3, minus 7 times star, t plus 3, equals 38. We get 5 stars minus 7 stars, that's negative 2 stars, equals 38. So if negative 2 times star is negative 38, we just divide both sides by negative 2. Get that star is equal to negative 19. 38 divided by 2 is 19. Positive divided by negative, negative. So if your star is negative 19, we said star is t plus 3. So that would mean t plus 3 is equal to negative 19. And then to solve for t, you just subtract 3 from both sides. Get that t is equal to negative 22. Right, the same answer that we had above. You can see, that was, I think, technically more steps than the first way. I think it was a little bit faster because you just have a little bit less actual math to do. But, it's another way to do it. And then you would check it the same way, just plugging that negative 22 back in for t. All right, we have another. How many solutions does the equation 12 times the quantity x minus 3 equals negative 3 times x plus 12 have? Let's just distribute them and see what it looks like. So 12 times x is 12x. 12 times negative 3 is negative 36. And then on the other side, we've got negative 3 distributed is negative 3x minus 36. All right, so in this case, they have the same constant, different coefficients in front of the x. So it's essentially like if you graphed this as a line and this is a line, and you're saying when are they equal, right? One of them's going up at a steep rate, one of them's going down at a slightly less steep rate. They're going to cross at one point. They have two different slopes. So, the only time that it's zero solutions is if they have the same slope or the same coefficient in front of the x, but different constants. The way it's infinite solutions is if it should be identical on both sides, or you should be able to manipulate it to be identical, whether that means distributing or whatever. In this case, it's neither of those weird cases, so it's exactly 1. If you want to prove that, you can even find what that exactly 1 is by just, solve for x. Add 3x to both sides, gives us 15x, cancels over here. And then we'd add 36 to both sides. And that would be 15x is equal to 0. So x is 0. So what might trip some people up is they'll find x. They'll say, oh, x is 0, so there's 0 solutions. No, this is your solution. That's one solution, right? So there was actually one on I think it was on the easy set. It might have been on the medium set where it was another one with one solution, but the solution was 3 or the solution was 2 or something like that. And then that was one of the options. It has exactly 3 solutions. But no, this is not telling you the number of solutions. This is the solution. Right? The only solution is 0. Right? So I guess that means if they have the same constant but different coefficients, then probably the solution is 0, right? X equals 0, right? But it's exactly 1. Since you have a calculator, I haven't mentioned this for the other ones, but for any of these questions, they say how many solutions are there, and they say how many. Just treat it as this is y equals 12 times the quantity x minus 3, and this is y equals negative 3 times the quantity x plus 12. Right? I know this is one variable, right? And there's a different set that's going to be linear functions, but treat it as a system of linear equations, and just see how many times do they cross. Are they parallel lines that never cross? That would be 0. Are they the same exact line? That would mean they have infinite points, right? All of the points on the line. Or are they like this, right? 2 different lines that are going to cross at one point. It doesn't matter where that point is, they cross at one point. All right, so that's another trick to do that one with your calculator. All right, we've got here some kind of table. The Townsend Realty Group invested in the 5 different properties listed in the table above. The table shows the amount in dollars the company paid for each property and the corresponding monthly rental price in dollars the company charges for the property at each of the 5 locations. Townsend Realty purchased the Glenview Street property and received a 40% discount off the original price, along with an additional 20% off the discounted price for purchasing the property in cash. Which of the following best approximates the original price in dollars of the Glenview Street property? This is all we need to focus on, is the Glenview Street property. Purchase price is $140,000. So the original price, we don't know. That's what we're solving for. The original price, they got a 40% discount, which means that's times 60%, right? Because 40% discount is 100% minus 40%. 1 minus 0.4, which is where I'm getting the 0.6 from. So they paid 60% of that, along with an additional 20% off the discounted price for purchasing the property with cash. So same thing, if you get 20% off, so 1 minus 0.2, right, 100 minus 20% is going to be 80%, right, so times 0.8. Now you can't just take off 20% from the 60, right? It's not just going to be 40% of that. It's you have to multiply it separately because it's 80% of the discounted price, right? 20% off of this, it's a different amount, right? Because 20% of the original was more than 20% of this new price. So, you can't just add the discounts. You have to multiply by 0.6 and then multiply by 0.8, which actually you could change the order you multiply them because it doesn't matter. That's the commutative property of multiplication. But times 0.6 times 0.8, you're ultimately multiplying by 0.48. Collectively, you actually got a 52% discount. Right, so you can't just do 40 plus 20 because that would be 60. You didn't get a 60% discount, you got a 52% because it's, you're paying 48%. Okay, so this is equal to the purchase price. I don't think the monthly rental price matters at all. Yeah, so this is also not important. All we care about is this 140. That's kind of funny. They give you all this extra stuff. It's just a big red herring, I guess. I guess it's kind of testing because this might be something you would actually need if you're doing some kind of project. They would give you more information than you need. You have to figure out which information is relevant. Which one are they talking about? All right, so we're just trying to find this original price. Let's call that P. So P times 0.6 times 0.8, that's P times 0.48 equals 140,000. So if you want to find P, you just divide by 0.48. And don't get confused with the 52 I was talking about. That's the discount you're getting. So 52% less than 100%, which is 48%. All right, and in this case, if you divide by something less than 1, the number will get bigger. So 140,000 divided by 0.48. Really, if you have a calculator, just type this into your calculator. Do not do what I'm about to do. If you do want to divide by a decimal by hand, you can always just turn it into a fraction, but we could do this. So we could go...
This is the same as, right, if you move this one over 2 decimal places, you have to also move this one 2 decimal places. So it'd be 1, 4, we've got 1, 2, 3, 4 zeros originally, 1, 2, 3, 4 zeros, and you have to add 2 more zeros. Like that. So it's 14 million divided by 48. 48 goes into 140 just under 3 times. So 2 times should be 96. Track that would be 44. 0 down, go into that 9 times. 9 times 48 would be, let's see, 480 minus 48. It's 432. We get an 8. And 0 down goes into 81 time. That's 48. 80 minus 48, 32. Okay, 0 down. This would go into 320. 50 would go into that 6 times. I think it's also 6 times. So 6 times 8 is 48. 6 times 4 is 24, which is going to be 28. 32. Just going to cycle through now. Right, so it's
291,066.67, like that. Now they round it to the nearest, looks like $100. So that would round this up to 700. All right, so it's 291,700. Now, if you typed this into your calculator, you would have just gotten this 291,666.67, and then it rounds it to the closest one. All right, so that makes sense. And if you want to check that now, you could just multiply this by 0.48. So multiply it by 0.6 and then multiply it by 0.8, and you should get 140,000. If you do it to this, then you'd get close to 140,000. That's another way you could do it. Once you have all of these options, since it's multiple choice, just multiply all of them by 0.6 and then by 0.8. So as long as you can set this part up correctly, you're going to get the correct answer, as long as you don't make some silly math error. Each side of a 30-sided polygon has one of 3 lengths. So there's 3 possible lengths for each of those 30 sides. The number of sides with a length 8 centimeters is 5 times the number of sides n with a length of 3 meters. So let's just write this out. So n, you can write let if you want. N is the number of 3 centimeter sides. 5n, so 5 times that, is the number of 8 centimeter sides. And then there's only one other possible side length. There are 6 sides with a length of 4 centimeters. So just 6 that are 4. Which equation must be true for the value of n? So you're not doing anything with the perimeter. They didn't give you the perimeter. So the actual numbers don't really matter so much. These ones are multiplying it. That would be to find the perimeter, where the perimeter is not 30. The number of sides is 30. So you can get rid of these right away. You're not multiplying by the lengths. The lengths are just to keep track of the different ones. So we've got n 3 centimeter sides plus 5n 8 centimeter sides plus 6 4 centimeter sides. And that will all add up to the total sides, which is 30. All right, so n plus 5n is 6n. 6n plus 6 equals 30, which is B. Okay, that's all you got to do there. So it's just, these ones are really not that hard. It's more just, can you keep track of all the words that they're talking about and not get thrown off by these the red herrings? It seems like the hard questions, a lot of times, what makes it hard is just that it has some red herrings in it, or it has a lot of steps. So here we have negative 3x plus 21px equals 84. In the given equation, p is a constant. The equation has no solution. It's another no solution one. What is the value of p? Okay. So in this case, the way that you're going to make it work is if this side, like the x's are going to cancel out. Because if you have like an x on one side and then no x's on the other side, but you have 84, right? There's some way, whatever you're multiplying x by, there's some way to make it 84. Right? There would be one point that works. But if you have 0 on this side and then 84 on the other side, right? There's no way 84 is ever equal to 0, right? So it's essentially like there's no x's over here, right? So it's like the slope is 0 on the right side. So to have the slope be the same on the left side, you need the slope to also be 0. And then for there to be no solution, that'd mean that the constants are different, right? So the y-intercept would be different if we're thinking of it as a linear function. Here, your like y-intercept, your constant is 84. Here, you don't have a constant, right? So 0 and 84 are already different. You just need to make sure that your coefficients are the same. So essentially, we just need to make sure that negative 3x plus 21px is equal to 0, which the important part of that is that the coefficient, so negative 3 plus 21p should be 0. We do that, just add 3 to both sides. You get that 21p is equal to 3. And then you just find p by dividing both sides by 21. And that would be p equals 3 over 21, which 21 has 3 in it as a factor. So just divide both of these by 3. That gives you 1/7. Right? If you want to test it out, just plug 1/7 in. 21 times 1/7 is 3. You get 3x. Negative 3x plus 3x is 0. 0 is never equal to 84. Right? If you plug in any of these other options, right, like 21 times 0, that would be negative 3x plus 0x. So negative 3x equals 84. There is a solution for that. What would it be? It would be 30 minus 2, so 28. 4/3, same thing, right? You're not going to cancel out those x's. 4, you're not going to cancel out those x's. 84 minus 3. Right, so the only way that it will work is if it's 1/7, or that it will work that there are no solutions. If x plus 6 over 3 equals x plus 6 over 13, the value of x plus 6 is between which of the following pairs of values? Between? Why are they doing between the pairs of values? That's kind of weird. To make this one easier, I'm just going to get rid of the fractions by multiplying by the least common multiple of the two denominators. So what would be the least common denominator if you were combining them. So we're going to multiply by 3 on both sides and multiply by 13 on both sides, which is the same as multiplying by 39 on both sides. Right, I'm just going to write that because you're doing them both in one fell swoop. X plus 6 over 3 times 39, that's like the 3's will cancel there, and then you just are left with 13 times x plus 6. And then on the other side, we're left with 3 times x plus 6. The 13's cancel out from the 39 here. Now we get what we distribute. You get 13 times x is 13x, plus 6 times 13, that's 60 plus 18, which would be 78, equals, and then here we have 3 times x is 3x, 3 times 6 is 18. So now we just solve for x, minus 3x, and I'll do minus 78. So it's going to be one of the negative ones, right? We can already tell that. This will be 10x. This will be 18 minus 78. Is that what it was? 18 minus 78 would be negative 60. So divide both sides by 10. Or you think what times 10 would make negative 60? X is going to be negative 6. Oh, you know what they might be doing is they wanted to make it multiple choice. They thought it'd be too mean to make it a short answer, but they thought if they give you the answer choices, then you could just plug it in and see which one works. No, this is what they're doing. This was really mean. Oh my gosh. All right. So you didn't have to do all of this because x plus 6 is what we're looking for, not x. So if x equals negative 6, then x plus 6 equals negative 6 plus 6, which is 0, right? Which 0 is between negative 2 and 2. But the other way you could think of it is the only way that, right, like the same numerator divided by two different denominators would be equal is if that numerator is 0. So x wasn't 0, right? It doesn't mean x has to be 0, but the numerator has to be 0. So this is 0 and this is 0. We're just solving for that numerator has to be 0. So it's between -2 and 2. And then they didn't make 0 an option because they thought that would make it too obvious, right? Like someone who didn't actually think of that wouldn't realize it's 0. So if you want to do it this way, I just did it the algebraic way. It doesn't take that long. Just be careful. I almost fell for the thing that I keep saying on the last 3 videos. Do not fall for this. They always ask for something other than x. They ask for x plus 6 or x minus 3 or 7x plus 2. Right? Pay attention to what they are asking for. Now you did see I did catch it, so just take the time to catch if it works. X plus 6 is 0. 0 over 3 equals 0 over 13. That makes sense. But yeah, you could do it this way if you want to do it algebraically. Just don't forget to add 6 at the end. Here we have -49x equals -98x. How many solutions does the given equation have? I think it's going to be 1. It's like they essentially have 2 different slopes, and that one answer will be 0. Right, so it's not asking what is the solution. Right, so don't fall for this. The solution is 0, but it's saying how many solutions. It's exactly one solution, 0. Because this is the slope is double this one. Right, it's like they both are crossing through. If you graph them as, again, treat them as if they're 2 different linear functions, which, they're not. It's a 1 variable equation. It's not a 2 variable linear equation. But if you graphed them, it would be like one of them, they're both super steep, right? So you have to scale it pretty, like this would be going up much faster than this. It'd be like that, like that. But this one's twice as steep going downward. So they're both going down, and they're both crossing through the origin. So it'd be like that, and then this one's twice as steep like that. But they just cross at that one point at the origin, and they never cross again. That's exactly 1. Here, what is the value of 2 minus 4x? All right, well, in the medium video, they did a bunch like this, and I, for all of them, showed how you could do it by solving for x, or how you could do it by substituting something in for what you're solving for. If you are unclear what I'm doing with this, you can watch the medium video and find some of those similar problems. They've descriptions in the timestamp, so you can find which ones are most similar to it. But I'm just going to do it the substitution way. So we'll say like t minus 4x equals, let's call it a, for that's your answer, right? This is actually what we're trying to find, the value of 2 minus 4x. So we've got, you can see there's an a there and there's an a there, right? The 2 minus 4x. So I'm just going to rewrite it, 5 minus 7, but instead of writing 7 times quantity 2 minus 4x equals 16 minus 8 times the quantity 2 minus 4x, I'm going to substitute in a there, right? So 5 minus 7 times a equals 16 minus 8 times a. Now we've got just one variable, much easier to solve. You don't have to do any distributive property, right? You don't have to distribute the -8. If you do the distributive property, just make sure you distribute the negative as well. Right, so that -8 times -4x is going to make a positive 32x, right? Or -7 times -48 is making a positive 28x. So don't forget that if you do it that way. But I would recommend doing it this way. So you just would get all of your a's on one side. So add 8a to both sides, gives us 5. And then -7a plus 8a is going to be 1a. So you just call that a. So 5 plus a equals 16. You think what plus 5 makes 16? It's 11. Or you just subtract 5 from both sides, which gives the same thing. A is equal to 11. And again, a is 2 minus 4x. So 2 minus 4x equals 11. If you want to check that, just plug it back in. So we'd go, all right, we have 5 minus 7 times 11 equals 16 minus 8 times 11. Well, 5 minus 77 and 16 minus 88. Which you can see the difference between 5 and 16 is 11. So you're subtracting one more 11 from it. Makes sense, it's 11 bigger. But 5 minus 77 is going to give you -72. 16 minus 88 would also be -72. Those 72 apart. So it checks out. Here we have the equation 9x plus 5 equals a times the quantity x plus b, where a and b are constants. So these, they are tricky because I think in your head you think one variable equations, it's going to be really easy. There's only one letter in it. One variable doesn't mean there's one letter because the letters can also represent constants here. Where a and b are constants and it has no solutions. Okay, so it's the same thing we've been doing. A bunch of these. Oh, they didn't format this very well. It should be the options are 1, a equals 9, 2, let me just rewrite this. So I is a equals 9, I, so 2 equals b equals 5, or is b equals 5. And then option 3 is b is not equal to 5/9. Which of the following must be true? We want no solutions. So we want the constants to be different, and we want the slopes, or I should say the coefficients in front of the x term to be the same. All right, so over here, the coefficient is 9. Over here, if you distribute the a, let's just distribute that a, it will give us ax plus ab on the right side. So that's equal to 9x plus 5. All right, so we want 9 and a to be the same. So they have the same slope, right? If you graph them as two lines, they'll be parallel lines with the same slope, but they have two different y-intercepts, so they never cross, right? That's how they have zero solutions. So 9 should be equal to a, right? Which is a equals 9, that's 1. So 1 is true. Then we also want the constants, so if you graphed it as a line, that would be your y-intercept, to be different. So 5 cannot be equal to a times b. Okay, so 5 is not equal to a times b, because otherwise they would be the same exact line. They're going to pass at every point. Or you think of it as like this expression would be the same as this expression. They would cross at every single point for x, and every single value of x. So since we know that a is 9, we can plug this in for the a here. And we could say that that means that 5 is not equal to 9b. And then to get b alone, just divide both sides by 9. I know my a and my 9 look the same anyway. Let me make a little more like that. And then the 9's cancel. That means that b is not equal to 5/9. So this is true. Which of these must be true? B doesn't have to be 5. Like b can be a lot, or b could be 5, but it doesn't have to be 5. It can be anything that's not 5/9. Because it doesn't have to be a specific, right? Again, if we're looking at the lines, it doesn't have to be a specific y-intercept. It just has to be not the same y-intercept. So it can be any value except 5/9. So 1 and 3 only. All right, and there wasn't even an option for all of them. So I guess once you knew it was 1 and 3, you didn't have to look at 2. But all right, really seems like make sure that you understand how to do these ones with infinitely many solutions, no solutions. They're a little bit tricky, but you have to think about it a little bit. But if you're comfortable doing them, they're very, very reasonable, and it can be a little fun, right? It's kind of an odd problem, but here we have a science teacher is preparing the 5 stations of a science laboratory. Sorry, laboratory. Instead of the way of like Dexter's, or no, they said Dexter's laboratory. I don't know. Each station will have either experiment A materials or experiment B materials, but not both. Experiment A requires 6 teaspoons of salt, and experiment B requires 4 teaspoons of salt. Let me just write that down. So A requires 6, B requires 4. If X is the number of stations that will be set up for experiment A and the remaining stations will be set up for experiment B, which of the following expression, there are 5 stations total. So this is X, and this is going to be 5 minus X for B. Right? Whatever X is, then it's just the other remaining ones of those 5 are all B. Which of the following expressions represents the total number of teaspoons of salt required? Okay, I'm not even going to look at like the options they have, but we have 6 for every station, and or for every A station, and there are X of those. So that's 6 times X. And then for B, you've got 4 per station, and there are 5 minus X of those stations. So it's going to be something like this. Let's look at the options here. They distributed it and simplified it. So let's just distribute that 4. 4 times 5 is 20. 4 times negative X is negative 4X. So 6X plus 20 minus 4X. If we combine our like terms here, 6X minus 4X would give you 2X plus 20. So 2X plus 20, that's option C. Oh, and that's it. Okay, well that was, I know each of those took longer than the easy and the medium ones, but there were a lot fewer of them. So I guess specifically linear equations in one variable is more a concept you're going to see the easy and the medium questions a lot more than the hard questions. It seems like a lot of the hard questions, what they're getting at, it's either like interpreting interpreting some kind of word problem in the form of a linear equation with one variable, or they had a lot of no solution ones, or like basically what would this constant have to be, or what would these constants have to be to make this have one solution or no solutions or infinite solutions. Just make sure you're very strong in those. Those came up a lot. They had one like this. These came up a lot more in the medium section. I don't really think this one was any harder than the ones that were in the medium section. Maybe the numbers were a little uglier or something, but I don't even know if that's true. But still make sure you know how to do it, because it could come up in that. So here's another one with like how many solutions. This one was interesting. So there's only one like this, like exactly like this. I mean, they had a couple that had to do with zero. Yeah, be careful. That you saw I almost goofed this one up, because I found what x was. X was -6. And then it was kind of just more pontificating why they were doing this. But if they do something weird like this, where they don't give you the actual answer as a choice, think, why are they doing that? And it could just be like, it would be too easy if you could just plug in the answer and see which one works. But it might be because it's like there's some trick with it. So in this case, maybe the trick was that if they're trying to get people to solve for x and then not realize that they did the wrong thing. Or I think it was more just they thought that if they said x + 6 = 0, it just like gave away the answer too easily. So maybe it's going to be like, if they're doing something where they're not telling you the exact answer and they're giving you options that are like ranges or domain, or I guess you could say it's domains because they're x values or x + 6, it probably means the answer is really, it's obvious once you hear it. Right? It's one of those things where maybe it's difficult to realize what they're looking for, but once you would see the answer, like, oh, that's definitely it. So if you don't have that feeling from your answer, then maybe take another look at it. And just be careful. They love doing this, whether it's an easy, medium, or hard question. They love doing stuff where they ask for not x exactly, but like x plus something, or x minus something, or x times something. I feel like the hard questions seemed like they had a lot more questions where they gave you unnecessary information. So like this one, they gave you this whole table. You only needed this one value from the table, and the rest of the stuff that you needed was just in the written part. I do think that, well, this is probably how I was when I was taking this test when I was in high school. If they give you a table and then they write this long thing, a lot of kids will just be like, well, I'm not reading that because I'm just going to look at the table. But if you don't read it, then you're going to be lost, because, most of the information you need is written in the description here. And it's not that long. Just, train your brain to not be lazy with, reading stuff like that. And they did do, I guess you have to be more comfortable with dealing with fractions. Make sure that you're strong with your fractions. They had some of this. Okay, so having to do with percent decrease. If you're doing percent decrease, make sure you know how to do that, where you can't just subtract the decrease from the other decrease. It has to be like multiply it by 1 minus that decrease. So that, it's kind of related to exponential growth and stuff, even though it's not actually exponential growth, but the same concept that you use for growth and decay. I know you could solve it another way, but there's another one where it's how many solutions. I think this was the trickiest one. So make sure, look at B7, E6, 394D. Make sure that you'd be able to set something up like this. I know in different parts it'll be similar stuff, but I think maybe it was just the one that I struggled the most to explain. I think I ended up hopefully explaining it pretty well. But if you've taken physics or chemistry and you've done unit analysis in that, I think that's more common than something you do in physics, but in chemistry you do it as well. Then that would make this problem more doable. Probably better ways to check it as well, like maybe actually try to solve the miles and see if it makes sense, right? If your number is less than a mile, that doesn't make any sense, right? Because we know we have to save 1.25 gallons, right? So you could use that to figure out, right, how far could you go in 1.25 gallons? 25 times 1.25. So if you get an m value that's 1.25 times 25, then you're on the right track, right? That you like for the value that you did here. If you get something that's less than 1 or way less than 1, then you messed it up. Okay. Or I guess it would be too big here. No, it would be too small. A lot of these ones with like the word problems, they had a couple, maybe there are 2 of these where they gave you a word problem where some of the information was a red herring still, like the table one. So just make sure that you're looking at the right thing and you're interpreting it right. And this one was also a tricky one, which is funny because it was the first one. So it made me think that they're all going to be a little more time consuming than they thought. Now, comment below if you found a faster way to do this than I did. Obviously explaining it as I'm going as well, so that makes it take more time than it would on the actual test. But This one did seem kind of time consuming. I do think it's not that challenging. And maybe part of the reason it was time consuming is because I was not using a calculator. So if you just type the numbers in, it's a lot faster. But this basically just had 2 different problems in one. Oh, I did have that trick. Yeah, for this one, you could realize that because it takes 5 hours to whatever, is it burn or what are they doing? Something with corn. 5 hours to remove 4,600, then it's going to take more than 10 hours, right? More than double that to go down by 11,000 or more than 11,000. So you know it has to be more than 10 hours so you can eliminate those. So that would be the trick to do that one a lot more quickly than what I did there. But overall, yeah, I think a lot of these should be pretty doable. Really make sure that you drill that, like how many solutions there are, infinite, 0 solutions, or just 1 solution. It's not exactly the same as when you do that for quadratics, right? That's like using the discriminant to determine like how many roots it has, how many times it passes through. And it's not exactly the same as how many solutions there are to a system of equations. You can use the same logic that you use for system of equations. It's much more like that than it is the quadratic, but it's technically a different thing, and the questions that they're asking for it are a little bit different. So, just make sure that you're very comfortable with those. Make sure that you're not thrown off by red herrings, meaning they give you information that's meant to like distract you or that you don't need to use. That's just an important skill with data analysis. Like you're always going to have more data, more information than you actually can make use of. So finding what's useful. And just making sure that your algebra skills are strong, and you should be good. But comment below if there are any questions you have, anything that remains unclear, if you have a better way of doing one of the problems or a different way, or if you think that I messed something up and didn't catch it, feel free to comment that below. And I'll try to either address it in a future video or maybe we'll address it in the comments. But thank you for watching. Hopefully this is helpful. I'll try to keep putting out some more videos with the other algebra problems, and then I already have the geometry problems up. I would like to hopefully get up all of the other math topics, and then maybe I'll even get all of the reading and writing questions as well. I know those aren't as big, the question sets, but they're pretty long and time consuming to do. But try to keep getting those up, and thank you for watching. Appreciate any feedback. Thank you.